Welcome to Crashcast Java, the podcast where we dive deep into Java concepts and make them accessible to all. I'm Victor, and today we're joined by Sheila to discuss an exciting topic in Java concurrency, the ForkJoin framework.
Thanks, Victor. I'm thrilled to be here. The ForkJoin framework is a powerful tool for parallel programming in Java, and I can't wait to break it down for our listeners.
Absolutely, Sheila. Before we dive in, let's set the stage. The ForkJoin framework was introduced in Java 7 back in 2011 to help developers write efficient parallel code. It's still very relevant today, especially when dealing with large datasets or computationally intensive tasks.
That's right, Victor. At its core, the ForkJoin framework is all about dividing large tasks into smaller, more manageable subtasks that can be processed in parallel. Think of it like organizing a big office project.
Great analogy. Could you elaborate on that for our listeners?
Of course. Imagine you're a manager with a massive project. Instead of assigning the entire project to one person, you break it down into smaller tasks and distribute them among your team. Each team member works on their part, and when they finish, they help others who aren't done yet. That's essentially how the ForkJoin framework operates.
That's a fantastic explanation, Sheila. This approach differs from traditional multi-threading in Java. In the traditional approach, you might create a fixed number of threads and assign tasks to them. But with ForkJoin, it's more dynamic and efficient.
Exactly, Victor. The key to this efficiency is something called the work-stealing algorithm. In our office analogy, it's like team members who finish their tasks early looking around to see if anyone else needs help, rather than sitting idle.
That sounds really efficient. Can you tell us more about how this is implemented in Java?
Certainly. In Java, the ForkJoin framework provides two main classes for tasks: RecursiveTask and RecursiveAction. RecursiveTask is used when your computation needs to return a result, while RecursiveAction is used for computations that don't return anything.
I see. So if we were processing a large dataset to calculate a sum, we might use a recursive task, right?
That's a perfect example, Victor. You'd extend RecursiveTask, implement the compute method, and within that method you'd decide whether to process the data directly or split it into subtasks.
Fascinating. Now I've heard the term ForkJoinPool mentioned in relation to this framework. What's that all about?
Great question. The ForkJoinPool is where the magic happens. It's a special thread pool that manages the execution of ForkJoin tasks. It creates threads as needed, up to a limit, and handles the distribution and balancing of tasks across these threads.
That sounds really powerful. Are there any common pitfalls or best practices our listeners should be aware of when using the ForkJoin framework?
Absolutely, Victor. One common pitfall is using ForkJoin for tasks that are too small. The overhead of splitting and managing tasks can outweigh the benefits if the tasks aren't computationally intensive enough. As a best practice, it's important to choose an appropriate threshold for when to stop dividing tasks and start processing them directly.
That's great advice, Sheila. It sounds like the ForkJoin framework isn't always the best solution. When might developers want to avoid using it?
You're right, Victor. ForkJoin isn't always the best choice. For simple linear tasks or when dealing with a small amount of data, a traditional approach might be more straightforward and efficient. It's also not ideal for tasks that involve a lot of I/O operations, as the benefits of parallelism can be limited by I/O bottlenecks.
Thanks for that insight, Sheila. As we wrap up, let's recap the key points we've covered about the ForkJoin framework.
Sure thing, Victor. We've learned that the ForkJoin framework is a powerful tool for parallel processing in Java, introduced in Java 7 and still relevant today. It uses a work-stealing algorithm to efficiently distribute tasks among threads. The main components are RecursiveTask, RecursiveAction, and the ForkJoinPool. It's particularly useful for processing large datasets or computationally intensive tasks, but may not be the best choice for simple or I/O-heavy operations.
Excellent summary, Sheila. For our listeners who want to dive deeper, here are 3 advanced topics related to the ForkJoin framework: custom thread factories for ForkJoinPool, the impact of ForkJoin on garbage collection, and integrating ForkJoin with Java's Stream API.
Those are great topics for further exploration, Victor. I'm sure our listeners will find them fascinating.
Thank you, Sheila, for sharing your expertise with us today. And thank you to our listeners for tuning in to Crashcast Java. If you enjoyed this episode on the ForkJoin framework, be sure to subscribe for more deep dives into Java concepts. Until next time, happy coding.